In this video, we're going to talk about complex zeros, in particular for polynomials. But before we get there, we're going to review this concept called imaginary numbers. Or complex numbers. And let's go ahead and talk about that right now. And I say review because some of you might have seen this before. But if you haven't, I'm going to kind of treat it like you haven't seen it before and go through those basics. So let's say we want to solve this kind of polynomial, x squared equals -1. That means I would take the square root of both sides, right? And I have a problem. Oops. And the problem is that I can't take the square root of a negative. What if we could take the square root of a negative? That's where the imaginary number I came from. So the most basic complex number is I, defined to be the square root of -1, commonly called an imaginary number. Oops, I don't know why I'm doing it in green. That just seems wrong. Let's switch back to red. Imaginary number. And any real multiple of I is also an imaginary number. So here's how it works. It's so cool. Previously, we couldn't take the square root of -9, but now we can. Because basically what we're going to do is we're going to break it up as the square root of 1 times the square root of 9. Because those, when you multiply together, is just the square root of -9. But square root of -1 is I. And the square root of 9 is 3. So what we have is 3i. Isn't that exciting? So exciting. We were able to take the square root of something we couldn't previously take the square root of. And that's how imaginary numbers work. And you're like, oh, is it that easy? And the answer is yeah. In fact, I is pretty cool. It's not too complicated. Let's see though, how it works. Now, I say it's not complicated, and then the literally next definition is about something called a complex number. And you're like, haha, it is complicated. They use the word complex, but this is the math word complex. Math words aren't the same as every other words in the human language. So a complex number is a number that consists of two pieces, a plus bi, where a is what we call the real part, or the real part of the complex number, and b is what we call the imaginary part. It's the part that's paired up with the I. In other words, we can have a real number in the world like 2 and add it to an imaginary number like 3i, and we're like, boom, it's taking a real number and adding it to imaginary number. It's a brand new number, which we're calling a complex number, 2 plus 3i. Okay, so let's see how complex numbers work. Let's say we want to add two of them together, like 3 minus 4i and 2 plus 5i. Well, here's what's really cool. If I want to add them together, I literally add the real parts and the imaginary parts. So I'm going to basically kind of do like terms. So I'm going to take the 3 and add it to the 2, which is 5. And then I'm going to take the -4i and add it to the 5i, and that's going to be positive 1i. And boom, we're done. It's another complex number with a real part and an imaginary part. Okay, so the only thing we really have to look at is I squared. I squared means I'm taking the square root of -1 and I'm squaring it. And when you square a square root, the square root goes away. So this is just -1. In other words, I squared equals -1. And this fact is a fact we're going to use when we start looking at more complex arithmetic with complex numbers. Complex arithmetic. Sorry, that was just totally an accident. More exciting arithmetic. There you go. All right, let's look at some. Let's multiply. This one doesn't have an example. We're going to need I squared, but the next one will. All right, so let's multiply. We're going to distribute. I don't know why I pressed the green there. We're going to distribute the real number and the imaginary number, literally as we would expect to do. And that gives us 8 plus 20i. Sorry, I don't know why I paused there for a second, but there you go. Okay, so let's multiply something a little bit more exciting, like 3 minus 4i and 2 plus 3i. Now here's where it's going to get fun. We're going to FOIL. And then we're going to actually have I squared, and we're going to see what happens. So we're going to distribute the 3 first, which is going to give me 6. Oops. Sorry, switch back to red. 6 plus 9i. Now I want to distribute the negative 4i, and that's going to give me negative 8i minus 12i squared. Okay, the two middle terms do combine, so that becomes just 1i minus 12i squared. But I squared, we know, is negative 1. So I'm going to go ahead, I'm running out of space here, and I'm going to instead write negative 12 times negative 1, which is positive 12, by the way, which I can now combine with the 6 in the front. So that's going to be 18 plus I. By the way, you'll notice in all of my answers, I always put the real number first and the imaginary number second. It doesn't actually matter, but it's the form of the complex numbers that we learned. So that's kind of why we keep it in that form. Okay. So what's really cool is we multiplied 2 complex numbers and we got out a complex number. That's just amazing when you think about it. They made up a number to be the square root of negative, and it ends up having some really cool mathematics. I'm very excited. I don't know if you can tell I'm geeking out a little bit here. Okay, so here's an exciting one, even more exciting if you can stand it. We're going to do a division with complex numbers. Now, we need a trick in order to do the division. Remember that secretly we're working with square roots, and you might remember from a long time ago that when you were looking at like the square root of, let's say here, I'm going to do something simple like 3 over 2 plus radical 5. I don't know, something like that. What you would have to do is multiply by the conjugate, which would be 2 minus radical 5. And you might kind of have like a vague memory about this. And what happens is when you multiply the denominator, well here, so sorry, the numerator is not exciting. That's 6 minus 3 radical 5. Okay, denominator is more exciting. What happens is we get 4, and then we get, I'm foiling right now in my mind right here. So I'm foiling those two. So 4, and then 2 times negative radical 5 is negative 2 radical 5. 2 times radical 5 is 2 radical 5. And then the radical 5s are going to be minus the square root of 25 or 5. But magically, because it's the conjugate, the middle term cancels out. That was the point. And the 25 becomes a 5 with no square root. And we've gotten rid of the square root out of the denominator. So that's 4 minus 5, which is negative 1. Okay, now that was an example to kind of refresh your memory on how you handle square roots in a denominator, which secretly that's what I is doing. So I'm going to use the conjugate. I'm going to multiply by 4 plus I over 4 plus I, the conjugate of the denominator. All right, here, I'm just going to leave this over here just for old time's sake here. Okay, so this leaves me with, here, I'm just going to finish simplifying then. Since that's going to be a negative 1 in the denominator, when we divide both of the numbers, that's going to be 6 plus 3 radical 5. Okay, so exciting. Let's finish over here. So we're going to multiply the numerator and the denominator. Now, the point is, in the denominator, we're going to get the middle terms canceling. That's the point. But in the numerator, we won't. So we're going to FOIL. And let me zoom in a little here, just so it's not so small. Okay, so 2 times 4 is 8. 2 times I is just 2i. 5i times 4 is 20i. And 5i times I is 5i squared. Boom. Okay, that's the numerator. Denominator is 4 times 4 is 16. Now, honestly, I don't need to write these middle terms because they're going to cancel. But for the moment, I'm going to do it just to show you. 4 times I is 4i. Negative I times 4 is negative 4i. And then negative I times I is negative I squared. Okay, let's do some simplifying. So in the numerator, the 2i and 20i become 22i squared. But I squared is also negative 1. And in the denominator, the two middle terms cancel. Boop. And I'm left with 16 minus, and then I squared is -1. So I have a double negative, which is going to become a positive. And what I have in the numerator then, I'll just write it out as a -5. And that's going to be 16 plus 1. Okay, so here's what I got. I got 8 minus 5 is 3 plus 22i over 17. Now, that's a good answer, but the final answer, we like to break it up so that we have a clear, distinct real number and imaginary numbers. So we like to break it up as 2 fractions. And there you go. We divided 2 complex numbers and we got a complex number answer. Not a very pretty complex number, but we can handle that just using the conjugate. They do define the conjugate down here. The conjugate of any complex multiple number, a plus bi, is a minus bi. Okay, real quick, just taking a second to understand what that means then. So if, if I'm looking at 2 minus 7i, the conjugate would be 2 plus 7i. If I'm looking at -3 minus 4i, the conjugate would be, oh, here, let me make it, yeah, that's fine. Conjugate would be -3 plus 4i. So see, the sign only in the middle is the sign that changes. What if it was something like 5i? Its conjugate is actually going to be -5i. Just because it doesn't have a real number part. But a real number doesn't have a conjugate because there's no imaginary part to switch the sign on. So only the imaginary part gets the sign switched. All right, great. Now, we'll use that information to look at complex numbers of zeros, but I'll do that in the next video.